Hi, I'm Aubrey Durkin. I'm with the Illinois Specific Learning Disability Support Project, and we are a federally funded grant project in partnership with Eastern Illinois University and Eastern Illinois Area of Special Education. We provide free professional development to the entire state of Illinois, no cost to anyone, and we also have an online platform with professional development where you can watch and get PDHs for your license renewal. I was a coach in Calumet City, born and raised in Dalton, so I see somebody's from Dalton there. And I spent most of my time as a coach and interventionist in Calumet City before coming on to this project about a year ago. So today's presentation will be what is dyscalculia, best practices for students struggling in math. This is a QR code for the resources that I will be mentioning today in the presentation. So anything that I'm mentioning is going to be found in these slides from Google Slides. And I think it's going to be dropped into chat also. Okay, so why is this a hot topic right now of students with specific learning disabilities in math? Well, this comes from the NAEP data in, I believe, 2022, and the grade level was 4, and the difficulty level was hard. But we would expect more students to get this correct, and it mirrors some of the data from the IAR and some of the rigor from the IAR. So we know that the IAR is a difficult test. Sometimes students that are projected to be proficient on MAP and WEA, sometimes students, in the 60th percentile or green will not be projected to be proficient. A lot of the times on IR, depending on the grade level, you have to be in the 70-something percentile to pass. So this does mirror some of that rigor, especially since it's a problem where you have to find more than one correct answer here. But we have about 19% of our students in the national public getting this correct in 4th grade and only 16% in large cities. So we want to see more of our students getting a problem like this correct. And then here, this is an 8th grade problem, and it is classified as an easier problem, but still we would hope to have more students getting this correct. So we have about 74% in the national public, and in large cities that falls to about 67% of students getting this correct, according to the NAEP data. So why is this important? 2022 NAEP data. Why is this important? Well, in 4th grade, the percentage of students at or above proficiency is only 16% for students with disabilities. And by 8th grade, students with disabilities, only 7% are considered proficient in mathematics. 25% of students have challenges learning math, and 4 to 6% have significant math challenges. And that really mirrors the numbers for dyscalculia of those identified of having dyscalculia. And then it's important because math scores correlate with future earnings. So right now there's a big push for the science of reading, and I'm so happy about that. But I know that mathematics kind of gets on the back burner, and it's so important as it can correlate with future earnings of students. So our objectives today are going to be to define dyscalculia with the best research that we currently have, to quickly explore a tool for evaluating your screeners of finding at-risk students, and explore evidence-based practices in math that research shows are helpful in helping students at the elementary level and foundational level skills that are struggling. A specific learning disability is a disorder in one or more of the basic psychological processes involved in understanding or in using language, spoken or written, that may manifest itself in the imperfect ability to listen, think, speak, read, write, spell, or do mathematical calculations. So underneath that umbrella term of specific learning disability, we have a mathematics learning disability. And in America, most often on IEPs, we will see specific learning disability in math, but overseas they'll use the term dyscalculia. So for this presentation, we're going to think of those interchangeably. So a specific learning disability in math, we're going to use interchangeably as per Hughes and Witzel research with the term dyscalculia. So dyscalculia is defined as presenting through severe and distinct challenges in math that require targeted, tailored, concentrated, and intense intervention, similar with dyslexia for reading. When we think of dyslexia, however, we usually think of one or two deficits, a deficit in pairing letter and sound correspondence together. And we also could think of a rapid automatic naming deficit. But for math, it's not so cut and dry. So it can manifest as a lot of different profiles. So I'll talk about various attributes that can be an indication a student could have dyscalculia. And another difference is that the research for dyscalculia is said to be about 30 years behind that of math research right now. So there's ongoing research that comes out, new stuff comes out daily, and I try to keep up with that research to be very current in the definition of dyscalculia. For eligibility in schools, dyscalculia is usually a clinical term used by a neuropsychologist, but that doesn't mean that your psychologist at school cannot use that term. If you're in Illinois, it's okay to use the term, but that's just the term that a neuropsychologist would usually use on their evaluation. And this is different than a student just necessarily struggling in math a little bit, although the treatment of both groups would be the same. So things that benefit students with dyscalculia also benefit those struggling in math. When we think of a student just struggling in math, maybe they're just hanging below the mean. They're not quite making as much growth to catch up with the mean. Students with dyscalculia may be stagnant in their percentile, not making adequate growth at all, and very low in their percentile. And this is over a long period of time. A psychologist may use the DSM criteria for SLD with impairment in mathematics, but it's just not one thing that a psychologist will use. They'll use many data points and measure it over time. So the deficits need to be present over a significant amount of time. Compared to peers, the scores on the math assessments are significantly below norms and significantly impacting their performance. And as stated, multiple tests are used. There is an overlap with dyslexia and dyscalculia, and I've read anywhere from 10 to 70% co-occurrence, which isn't very helpful, especially if you're a math person. But usually the number that's settled on is about 40% overlap here. And it's very interesting to denote that students with just dyslexia and not diagnosed dyscalculia can still have issues with math as well. So students with dyslexia, dyscalculia, and both groups have a hard time solidifying their math fact bank. They may need more exposures to get those facts into long-term memory. And so, Matthew Burns did a study, and on a particular multiplication problem, he studied many multiplication problems and how many exposures students need to retrieve those. And students that were working above grade level needed about 6 exposures to master that fact. Let's say it was 3 times 7. Students working at grade level needed about 8.25 to master that new fact. And students struggling in math needed 11 plus exposures. So the science isn't settled on this, but we know that students in both of these groups separately and together need more exposures usually to master those math facts. An interesting thing to note as well is that students with dyslexia sometimes have a co-occurrence of ADHD. So it's also something to look at, and the science isn't settled on whether they're actually taking the problem in and focusing in that exposure to gain that new content. So babies are actually born with an innate sense of number. They've done studies on babies because somebody had a lot of time on their hands apparently, and they put dots in front of babies about 6 months old, and the babies stared at the dots, and when they put a different amount of dots, the babies stared longer as if they were processing and taking in that information. And then when they went back to the original amount of dots, the babies kind of looked away as if they weren't taking in that information. And so they were able to discover that the babies could discriminate between about 8 and 16 dots, and they could notice a difference, not with one-to-one correspondence, but notice a difference in the amounts. And as that got closer together, the babies were unable to discriminate between like 9 and 10 dots and things like that. But it just gives us a picture that we're actually born with a sense of number and with a type of approximate number system. And this is mirrored in the animal kingdom as well. When a group or a pride comes upon another group, they quickly have to gauge the numbers and estimate. Now, when we get to preschool, there are several challenges that could emerge, but it's important to note that we shouldn't say a student is at risk until we know that they've been exposed deeply to these concepts. So if a student is just in school for the first time and this is new, they may have a lack of exposure that's not helping them to understand these concepts. But these attributes are assuming that these students have seen this multiple times and they're still struggling. So these are students that rattle off 1, 2, 3, 4, 5 with no understanding. They're just memorizing that. There's no understanding that when they count something, the fifth is not that object, it's the whole set. These students also may have difficulty giving you an amount. So maybe they can count with one-to-one correspondence, maybe they can't. But if you ask them for 4 items, that's a whole other conundrum for them to actually give you a set of items. Short numbers, such as your room number, 108, let's say the room number is 108, and you've said the whole year, you're in room 108, you're in room 108, and they're still struggling with that 108, that may be a sign that they're at risk in mathematics or that they have a specific learning disability in math. And then time, I wouldn't expect them to read an analog clock, but not having any kind of sense of time or time passing and being just kind of grossly off in their sense of time. Like, we're going to do that 3 weeks ago or something like that. We also have some issues understanding and saying correctly directional words, especially if it's a visual spatial profile of dyscalculia. So under, over, around. There may be an avoidance of building block structures, again, with the visual spatial profile. And there may be no rhyme or reason to their counting. So we see 3, 4, 6, 9. It actually is appropriate for preschoolers to maybe skip a number in a sequence, and with repetition, that should go away. So if they say 1, 2, 3, 4, 5, 7, that's appropriate. With repetition, that should go away. But at this time, if there's just no rhyme or reason, that's not appropriate, especially if the exposure has been there. It's also important to note that reversals are completely appropriate. It's more of an ocular thing than a developmental issue. So reversals of flipped numerals, that's not a sign of dyscalculia, and that is seen as something that's a normal developmental thing up until almost 2nd grade. And then we have subitizing. So right here, we have a 4. And we know that's a 4. We don't have to count with one-to-one correspondence. And a student with dyscalculia, even with some exposure, they may need to count with one-to-one correspondence to make that amount real to them. And so when we just look and can count, that's called perceptual subitizing. And then the 6, what we're actually doing is called conceptual subitizing. So we're quickly seeing those 2 3s and we're putting them together to make that 6. And new information coming out from Noel and Kara Giannakis is saying that we can focus on the conceptual subitizing. So these students can really benefit from things like cluster cards or cards in which they can see amounts and see the amounts within the amount and decompose the number. So working on the conceptual subitizing component. Getting into elementary and middle school, there may be difficulty navigating the number line. And a lot can be said about a child's approximate number system. If you were to give a child in 1st, 2nd, 3rd grade an open number line, and you have them put a 0, semi-graded 0 and 100, and you ask them to place a number such as 27. Where they place that number is going to tell you a lot about their mathematical sense, their number sense, and their approximate number system at that time. And then, as we stated before, getting those facts into long-term memory, we may have these students not understanding that 146 is different than 461. They're seeing the same digits. They think it's the same thing and not understanding that the place value makes the value of the digit different. When I started this project about a little over a year ago, it was said that there was a working memory impairment with dyscalculia, and there's a little bit of controversy around that. So Dr. Daniel Ansari has cited some research to say there is a working memory impairment, but then other current research says that if a child is having difficulty memorizing their math facts, if given a multi-step problem, that could look like a working memory impairment, but really they just don't have their fact bank solidified. So that science is not yet settled. And in elementary and middle school, interpreting graphs, tables, charts, coordinate plane can be difficult. Continuing in elementary and middle school, these students don't yet have the breakable chain. So what I mean by that is if you have a student in elementary school where they're doing 5 plus 3, and they go 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, right? They're not able to understand that they can start with the 5, 6, 7, 8. They don't have a breakable number chain. They always have to start with 1 and make the number real to them. And then this is actually something that impacts students with dyslexia as well, but following sequences or orders and things. So here we have PEMDAS or your order of operations. They may know how to do the computation, but remembering the steps may be difficult. There also is a co-occurrence of dysgraphia, which is a writing disability, with dyscalculia. And so you may have alignment issues. So we've all had that student where they're writing and it's going off the page. The algorithm is completely not aligned properly. And so they're getting incorrect answers just because of that. And then getting vocabulary terms into long-term memory for dyslexia, dyscalculia, both groups. That is hard and it takes more exposures usually. And we have here motivation. So at this time, it gets into kind of the social emotional component. Students may have labeled themselves as bad at math, and they may then self-fulfilling prophecy, not put in the effort to become better at math. And I've had parents before tell me, I know why they're bad at math. It's because I'm bad at math. And I say, no, 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 we don't want to say that, right? Because you just demotivated and took the power away from the kid to try to put in the effort to become better. And so one of the biggest, most powerful things is that success is the biggest motivator. So getting these students to experience some kind of success at some level is going to be the motivation that they need to continue to pursue mathematics. There's not an extrinsic motivator that's going to work as well as that does. And challenges for high school, there may be an over-reliance on the calculator and a lack of, confidence in their own ability. So they're going to go ahead and put 8 plus 2 into the calculator. And then that's not helping because they need the more exposures and the more opportunities to retrieve. So a suggestion from Rebecca Lord in the Lord Math Dyscalculia modules was to have these students use calculators to access grade level content, but then still have an intervention time for them to work on their fact banks and memorizing their facts. Because most students, according to Brian Ponce's research, even students with intellectual disabilities can get those facts memorized. We just may have to change the amount of facts that we're working on at a time. There may be budgeting issues with their money and keeping their money correct and knowing how much money that they have or how much money it's going to take to purchase something, navigating that coordinate plane, putting information into graphs and charts. And then there may be directional deficiencies. So I was listening to a podcast and a woman was 23 and she was still struggling to get her license, not only because of directional issues, but she was struggling with depth perception. Okay, so that's a lot, right? So as I stated earlier, it's not just one thing that's going to point to dyscalculia, but a student struggling at math for a longer amount of time. But according to Kara Giannakis and Noel, it can be boiled down to about 4 profiles, and students may overlap into one or more of these profiles. Core number is huge. So it's actually a bigger predictor of students in the earlier grades comparing core number Arabic numerals. So the numeral 4, the numeral 14, being able to compare those will be a better predictor of a student being at risk than being able to compare amounts. So if you have an amount of dots and students can compare that, that's not as big of a predictor of an at-risk student as comparing Arabic numerals. There also can be a reasoning deficit in which students may have a piece of information such as they know that the area of a circle is pi r squared, that you square the radius and times it by pi. They know that the radius is half of the diameter, but given the diameter, they somehow can't put those pieces of information together and apply that to solve a new problem. That would be more of the reasoning. Memory falls into the category of having a very hard time, multiple exposures to memorize facts and vocabulary. And then visual spatial has to do with navigation of the coordinate plane and those things, but it also has to do with decimal placement and place value. So just some key takeaways. These are the categories and also big predictors. One of the biggest predictors a student will be at risk with math is when they see 3 Arabic numerals, not amounts, but the numerals, being able to say, are they ascending, descending, or no order? So are these numbers going up in amount? Are they going down in amount, or no order? That's a big predictor that a student will be at risk in math if they're unable to do that in the elementary level. Navigating that number line, and then also fluid reasoning. So those students who, when doing 99 plus 17, 99, 100, they have a strategy that will get them maybe the correct answer, but it's not efficient enough and often leads to errors. So they can't say, oh, I'm going to take one from 17 and make it 100 and kind of fluidly reason in that way. So now I'm going to take a minute to let you guys discuss, if anybody wants to come off of their mic or put into the chat, excuse me, what do you see the most out of all these challenges I've listed with your students, or what do teachers say that they see the most, and what do you feel benefits these students? Early numeracy skills? Motivation part, yes. I feel like it is a self-fulfilling prophecy sometimes, because then they're not paying attention because they've already labeled themselves bad at math. The subitizing. Yep. Fact fluency. And Allison, we're going to get into some really great strategies to help them with their fact fluency as well. The fact memorization. And I'll touch on this a little later, but since it's coming up a lot in chat, there's actually some new research. Robin Cotting, the IES Practice Guide, talks about timed tests and bringing back flashcards. And so it's funny because there was just an article out that's basically saying flashcards are king. Like flashcards done, incremental rehearsal in a specific way, even students with intellectual disabilities can access facts if you narrow it down to about 4 facts at a time and you work on those 4 facts and give about 12 exposures. So the fact fluency is an issue, but hopefully I'll be able to show you some resources that help for students struggling in math with the fact fluency, and they're completely free. It was also thought that fact fluency, that time tests were causing anxiety for students. And so people kind of moved away from time tests. And the newest research is saying no, when a student is 90% accurate, so when they can come up with an answer, but it's taking them a little bit of time to do so. So they're counting on fingers, they have a strategy to get the answer, but not within 3 seconds. If you do time tests, it does not cause anxiety. They know that they have answers for it. You keep it low stakes, and it's not causing anxiety when they're about 90% accurate and you're trying to get them faster, because we know that fluency is about within 3 seconds them answering it. And that's not to say conceptual understanding isn't important. It's very, very important. But the newest research is saying as well, I know I'm saying a lot, but it's a bilateral. So they can actually learn a fact first from memory, and they can deepen their understanding conceptually. So it doesn't have to be the trajectory that was once thought. Okay, so you should see a picture of the brain on my screen, hopefully on your screen. And dyscalculia is said to be affected in the parietal lobe, which is perception, making sense of the world, arithmetic, and spelling. And the right interparietal sulcus, which is a fold on the right side, has less gray matter in some circumstances, as well as when most people look at a quantity amount, that side lights up. But for these students with dyscalculia, it's not lighting up in the right interparietal sulcus. Instead, there's a bilateral compensatory activation in their left interparietal sulcus, which would be more like of the symbolic side and the language side. So we can reason from this that when students see an amount, they're not able to necessarily tie it or understand the symbolic that aligns with it, because it's not activating when they see a quantity in their right interparietal sulcus. It's just activating on the left side. So pairing those together, symbolic 3 is equal to 3 dots is equal to a language, the word 3 is difficult for these students. And dyscalculia is that underactivation in the interparietal sulcus. In both dyscalculia and dyslexia, the angular gyrus is said to be affected, so there's an overlap there. And then in dyslexia, there's an underactivation in the left temporal parietal area. So there's a little bit of a difference in the brain abnormalities there. And here is just a really good graphic to show us that this 3, that's not lighting up when they see those quantities. And instead, 1 and 2 can be lighting up instead of that. Okay, so now I'm going to show you a tool that will help you hopefully in evaluating your screeners, and then we'll get into the best practices for the students that have dyscalculia, as well as those struggling in math. And I just want to make sure you guys can see where it says tools chart. Yes. Okay. Can you guys see where it says tools chart on here? I'm just making sure that I'm sharing the right one. Okay, thank you, Susan. Okay, thank you. Okay, so we're gonna go to NCII tools chart, and then we go to the actual. Sorry about that. There's an academic screening tools chart as well as an intervention tools chart, and it basically lays out the research of these tools or these screeners. So it says if it has convincing evidence, partially convincing evidence, or unconvincing evidence based on their research, that these are going to be effective at finding your at-risk students. So you can toggle mathematics here. It's on NCII. And then we see Acadian's Math. That's actually a free screener. So I'm not going to knock it. It's a free screener, right? So, but there are some things here that we could note. It's partially convincing that it has evidence to find all your at-risk students. So if you are using some of these screeners, you might want to think of supplementing with something else that's maybe more of a mastery outcome or something else to try to find those at-risk students in certain areas. And we can go down and we see, NWEA here too, FastBridge, MAP. So we see MAP. It's harder at finding all the at-risk students in kindergarten and grade 1. That could be because the students are learning how to navigate it, as well as maybe they haven't had enough exposure to that topic. And so it's going to be partially convincing evidence on finding that. They also have a tools chart for their academic interventions. And some of these I'm going to be mentioning later. So I just want to show you the research on them before I get to them. If I apply the filters for this, cover, copy, compare. So using that in mathematics, it may work for some students. There's some controversy in the research. We have some unconvincing evidence in these research studies, and then we have convincing evidence here, Robin Cotting in her study. So that's something we might want to look a little deeper in and use as a case-by-case basis. Incremental rehearsal is basically using flashcards and really narrowing it down to facts and being very conscious of the facts that we're using in the flashcards. So that has a lot of convincing evidence for helping students with their math facts, as well as taped problems, which is my new favorite. And we'll talk about that towards the end of the presentation. A lot of great evidence to show that this helps students in mastering those math facts. And it's important to note that when we're looking at our at-risk students, that we have a scope and sequence for these students. So on the NCII website, they do have free modules where they talk about math and give kind of a scope and sequence for certain skills. So this is the scope and sequence that they give for fluency. It's all free. You can go through the modules free. And then we also have the Achieve the Core K-8 document. And I really like this because it can help you understand and boil down the standards to the meat and potatoes that students need in order to access algebra. So if they have components of this that are missing, they're not on pace to access algebra. And these are all linked into the resources as well. Okay, so now that we've defined dyscalculia, explored that tool for evaluating screeners, we're going to get into those evidence-based practices. And this comes directly from the What Works Clearinghouse IES practice guide for students struggling in math. And this guide actually focuses on the elementary level, but much of it is reiterated in the 4th through 8th guide for problem solving. A lot of these things are reiterated in that, as well as the accessing algebra guide as well. And the science of math is a newer movement, and it's focused on that objective evidence. And they have a website too with a lot of their debunking of some of these math myths. Here's a picture of the math rope as well. And I like to show this even though it's a little old, just to show there are many facets to math. And so there are a lot of different things that students need to focus on in order to access a math problem. Okay, so we have our best practices. And we're going to focus in on these best practices. And they all have strong levels of evidence that they're effective in teaching students struggling in math. We have explicit instruction, precise math language, using multiple representations, number lines, word problem attacking by type instead of keyword, and then having timed fluency activities. Explicit systematic instruction. So when we're instructing students, we want to explicitly show them how to do the work. So more of an I do, we do, you do model. And once they're comfortable with that, we can start to play around with inquiry-based when they've mastered some of these skills. A lot of the research about inquiry-based is studying students that are graduate students or expert in their fields and how they learn. But we know that students that are struggling in math and elementary students learn best when they're given explicit systematic instruction. We want to mix it up, meaning when we're starting to teach a new topic, we want to tie back to concepts that the students have already learned. And we want to start easy with maybe solved problems so that they can just focus in on what is happening in the algorithm, and accessible numbers so they're not bogged down by the computation when they're first seeing a new type of problem. And then we want to sequence so that the math builds upon itself. And these are the direct recommendations within the guide. So here we see that it's in Hattie's zone of desired effects, explicit teaching strategy. And this is the I do, then we do, then you do model for this. And here we see in the orange modeling, we're going to give step-by-step explanations with planned examples. And then we're going to have practice that will be guided and then independent. And a good thing that you can do is if you have an independent practice page, you can pick out a teacher check. So what I would encourage your teachers to do, or what you can encourage your teachers to do, instead of reinventing the wheel with exit slips, they can pick out a teacher check on the independent practice page that mirrors all of the levels of depth within the standard that they're working on. And if they pick out, let's say, have students circle number 2 and 7, they have to get checked then by the teacher, by the paraprofessional, or by the co-teacher before they can move on. And that's helpful because we don't want students sitting there practicing wrong. If they're practicing wrong, we're going to have a hard time to undo that. So this stops that, and then you give them a little bit of feedback, like you got this incorrect because this, and then you sign another problem. Now, the students who have gotten these problems correct are at their desk working, and we can trust that they probably know what they're doing. The ones who come back up, once we've redirected them once and given that immediate feedback, if they're still struggling, then we know immediately what our small group is going to entail and who needs that more intense intervention and instruction. This entire time, we're asking high-level and low-level questions. We're giving frequent opportunities to respond. And that can look like whiteboards. I'm really big into whiteboards. A lot of educators that I've been listening to recently have been talking about whiteboards and having kids constantly write with their hand their thought process so that everybody has consistently a chance to respond. Sarah Powell suggests having students have a chance to respond once every 60 seconds. So that could be thumbs up, thumbs down. I think sometimes students just then start putting their thumb up, thumb down. So I like them writing with their hand on a whiteboard. And research shows that when students write with their hand, or when people write with their hand, they retain more than even typing or just listening alone. So when you're writing with your hand, you're retaining more, as well as if they're looking at something that's not a screen, you also retain more. So reading off of a screen, people score less on an assessment when they've read it off of a screen than paper and pencil. So kind of taking a step back and realizing that the students writing on their whiteboards is something simple but really beneficial. You want to provide that immediate feedback, correct those errors, and keep a brisk pace. This may help some, but not all of your behavioral issues. And here's an example of a rounding procedure. I like it because it's color coded. You can have examples there, worked examples for them to focus on first and just describe what's happening in the procedure and then go ahead and try the procedure on their own. And this was another example that didn't go as well. It was something I created, but I realized that it was a little too wordy. So I ended up taking out the bold steps and then having the students just write with their hand in that procedure. They had notes buddies to make sure that they were writing the procedure correctly, and they used it as a near point reference, but the unbolded parts were already filled in for them. And then I like it too because of the color coding, but again, it was a little too wordy for them to write out the entire thing. So when we're doing explicit systematic instruction, we want to be concise yet clear, color code if applicable, give them steps and a procedure. The students can follow along even with a little bookmark adhesive tab. They can follow along with the steps, include worked examples, and then relate it to a mnemonic if appropriate. So that's specially designed instruction, is having the students come up with a mnemonic or a way to remember the procedure for themselves. The second practice is using clear, concise math language. So here we see an example where the teacher was not using clear, concise math language, and it ended up making the data worthless. Mr. Hernandez is teaching his students about adding improper fractions. To make it easier for some students, he refers to the numerals in the fraction as top number and bottom number. On the test, students are asked to find the least common denominator of a half and 4/6. So now we don't know on this data, do the students not know the term denominator, or do they not know how to do this skill? So the data kind of becomes useless because we haven't used those higher level terms. And I say the earlier the better, use these higher level terms. If students understand it, great. If they don't, it was the first exposure, and at least they have a background to tie it into the next time that they hear the word. And this is research from Sarah Powell in her 5 best practices for math instruction. And these are the amount of new terms that students are expected to master every year. So by 6th grade, it's over 500 terms in that year alone, getting them ready for algebra. So that's a lot of new terms that the students have to be expected to learn. Students with difficulties in math often experience difficulties in reading as well. So we want to teach mathematical language that can be used across the grade levels. And we want to make sure it's matching our assessments. So if we're using particular terms that don't match our assessments, then we don't know if the data is accurate from the assessments. So when we're teaching mathematical vocabulary, instead of bigger, larger, smaller, if you want to put in chat what we could use that would better match an assessment language or word. Greater, yep, greater, fewer, less than, least. These are all words that we're going to see on an assessment. We're probably not going to see bigger or larger on assessment. What about reduce the fraction? I grew up reducing and borrowing. What can we say instead of reduce the fraction or the fractions are the same? Simplify, yes. Because if we think of, or put in lowest terms, sure. So if we think of reduce the fraction, reduce implies to get smaller, right? But this fraction isn't getting smaller. The quantity is remaining the same. It's just put in a different form. And then we have equal value, equivalent for the fractions being the same. 1.29, we want to say 1 and 29 hundredths. I know it's way more syllables, right? But it's really setting them up for success when they're then changing it into a fraction. They can hear 1 and 29 hundredths. They can hear it and more easily change it into a fraction. You can't take a larger number from a smaller number. And I'm seeing in the chat, if anybody would like a copy of the slides at the end, you're more than happy. I would be more than happy, excuse me, to give you a copy of the slides and email that out. So this was a rule that actually, right, this was a rule that actually expired. And so little side note, I have 4 kids. So when I was on the second one and I was like caring a lot more and I was like pushing him to do more, he came home in 2nd grade and he's like, I was trying to get him to do 2 minus 4. And he's like, Mom, you can't do that. you can't take a larger number from a smaller number. And I'm like, yes, you can. And then he was mad at me because I called his teacher a liar and there was crying. So basically, I would like educators and myself to say, for our purposes, what we're doing right now is we're taking smaller numbers from larger numbers. But in the future, you may take a larger number from a smaller number, and that goes negative. Kids as early as second, third grade can understand that. Multiplication makes an amount larger. Well, we know if you're multiplying by a fraction, that's not the case. So if we're using that terminology, we need to have a caveat that multiplication makes an amount larger if we're talking about whole numbers greater than 1. Then it's going to make the amount larger, or two numbers that are larger than 1. And then these are some high school examples with imprecise language. I'm not knocking FOIL. I like FOIL as a mnemonic, but we still need them to hear the term distributive property. So there's some examples from Hughes' article. And then also STI with these students, having them physically act out, come up with a mnemonic or a picture to remember terms is really, really helpful for these students. So if they're doing supplementary, having them use their arms or hands to act that out. Acute, having them use their hands in different ways, right? Because acute angle doesn't have to be in one way. Or we used to have our students do degrees by standing up when we'd face the front, and I'd say 90 degrees right, and we'd jump and go to the right. And that was a good formative assessment for me on their understanding. And then we tried 360, and then somebody fell, and then that was the end of that. But it was fun while it lasted. And the students were really showing me that they knew degrees, and they were showing me with their hands, and then they were able to understand that. So here are some ways in which my students came up with to remember what these terms mean. And I think it's best when the students come up with the ideas themselves, as long as they're checked that they're mathematically accurate, because they remember them better when they see the terms. So here we have perpendicular, and a student just put two perpendicular lines around it. And that was how that student remembered perpendicular, and it worked for that student. Here we have acute. They drew it as if it was acute. Hexagon, I had a kindergartner. I said, how are we going to remember that hexagon? It has 6 sides. And they're like, duh, there's an X, hex 6. I said, okay, great. Supplementary is S, straight is S. Using the alphabet to help is really beneficial. I had a student point out to me in changing decimals to percents. So they started with the D and they're changing it to a percent. And we talked about the whole conceptual piece. And then they decided, well, I'm just moving from D to P, so I'm going to move to the right in the alphabet. So that helped them to know which way to move their decimal point, even after we talked about the conceptual component. And then I had a student that just literally put a stop sign for the O in octagon, octopus for octagon that has 8 sides. And then fun fact, that's not very helpful. October was the 8th month, but they added in January and February and they messed that all up. So October was supposed to be the 8th month. Parallel, they drew parallel lines. And then I think it's really important also from a very early age to say things like the fraction bar is a dividing line so that they understand. Top dog in the house, it's 2 divided by 5. This is a dividing line. This denotes division. And it looks like the division symbol as well. We have a bar here, and then we have 2 amounts on either side. So it looks like a separation. When we're simplifying our fractions, we are really dividing by a form of 1. If we have 2/4 and we're dividing by 2/2, 2/2 is the same as 1. So I have students write that big 1 around it to show that they're getting the same fraction in a different form. And then talking about what pi really means conceptually, as well as why we multiply by the reciprocal. All of those things are really important for students to understand the piece behind it and not just the algorithm, although that's important too. And then a remainder is your new numerator. So I tell students as soon as they see a remainder that that's actually a part of a whole, and that helps them a lot when they go to change improper fractions to mixed numbers. And here we have an example of how to tackle those vocabulary words. We can have Cornell notes where they write the terms on the left. Here's an example of that. So we have isosceles triangle, kite, quadrilateral, and then descriptions, whatever description they want. These are called triangle truths, and it's just like 3 attributes of it. And then the big bang for your buck is where they're writing like a mnemonic or something to help them remember the terms. So here's something as simple as quad has 4 letters. We have a quad, it's a 4-wheeler, and that's a quadrilateral. And these are called, it's a variation of Cornell notes. Okay. Practice number 3 is using multiple representations. We want to show students different representations and connect to the abstract math while giving a lot of opportunities for the students to work with those manipulatives. So we have CRA, and it was used to, the main thought was used to be that you have to start with concrete, right? And then you move to representational. So your concrete tools would be like your Cuisinart rods and using these to do division and multiplication and all those things. And then you move to representational. But the newest line of thought, and this is what they do in Asian cultures as well, is this is bilateral as well. So we can start with concrete, but we want to actually show that algorithm that goes with it. We want to show the abstract algorithm in conjunction so that the students understand that they're talking about the same thing and they're not exploring two different concepts. So when we have a lot of place value blocks, but we don't have students writing with their hand the algorithm, sometimes they think those are two separate concepts and aren't understanding that that's the same concept. So here we get the most bang for our buck when we're doing all of these in conjunction with each other. And we do have online free access to one of our videos where we go into Cuisinart rods and cluster cards, because those are really, really good for students with specific learning disabilities. And if you are interested in that, go ahead and put it in chat and I can try to send you that video of the concrete manipulatives, which involves going into Cuisinart rods, cluster cards, and things that specifically help students with dyscalculia. Here's examples of concrete tools, but we have to remember that no matter how many resources you have, it's not enough if people don't know how to use them. So you can lay out all the manipulatives in the world. You really want to stick with about 2 manipulatives per skill and really get them acclimated with explicit instruction on how to use those manipulatives. And that is the link, sorry, that is to the other presentation, but. And here are some examples of using representational drawings. So having flashcards with meaning so that they can see pictorial representations. And then on the back, putting that abstract algorithm so that they make the connection and work flexibly with math. And this is a free website that actually has those. All of the things that I'm referencing are also in the resources slides. So every website that I'm referencing is found within there. The number line is practice number 4. We want to show all numbers on the number line, compare quantities, and use operations. This has been shown to be very, very beneficial for students with learning disabilities in math. And I never grew up with the number line, so I was very reticent to use the number line in instruction. And we adopted a curriculum that relied heavily on the number line. And I saw such gains in the students. It was amazing. They did a lot of problem strings where they would build with a number line, with an open number line, and with a graded number line. So we want to show all number lines. We even want to introduce that vertical number line early. That way, when they get to the coordinate plane, it's not as confusing because they've seen it before and they know negative numbers are going to be going down. Here's an example of using a clothesline across the room and having students place things, and that can help you with a formative assessment of their knowledge of fractions and decimals. And then also I've had students where if you tell them to break it into 6, they're going to draw 6 lines and they're going to break it into 7s. So having them understand that this is not 1/6, this hash mark, it's a unit here. So this is a unit that we're talking about. And having them use something like Unifix cubes to help them create their number line can help them avoid problems of being sloppy and having a number line that doesn't have even increments. Okay, so 2 more, quickly going over these last 2. It's word problem instruction. And this is looking at word problems and identifying an action, all right? We know that a problem like this has students doing so many things to complete it. They have to read it. They have to understand the vocabulary that's involved, identify relevant information while ignoring irrelevant information, while interpreting charts, while identifying the appropriate operation, while performing the computation. So that is a lot for students. It's no wonder that they're struggling with word problems. So when we have a keyword strategy and we tell students that a keyword always indicates a certain operation, that can be detrimental for students. Here we see the word altogether. A lot of the times we tell our students, you see altogether, you're going to add. Liz had 3 red crayons and 2 blue crayons. How many crayons altogether? If I add, I can get the correct answer here. But here we have 2 keywords. We have our each and our altogether. Liz had 4 boxes of crayons with 8 in each box. How many altogether? If the students add here and they don't repeatedly add the 8, but just add 8 and 4, they're going to have an incorrect answer. So according to Sarah Powell's research, she found that, and this is the most important part, in a 2-step problem where students were just answering by using a keyword and the usual affiliation. So a fewer, you usually subtract. They thought they were telling students to do that. In a 2-step problem, students were only getting the problem correct about 10% of the time when they were relying on keywords tied to operations. And that's because you could have a problem in which Jimmy is 8 years fewer than Margot, and we're given Jimmy's age. Jimmy is 10, and we have to find out Margot's. So it's not always that we're going to subtract when we see fewer. So what now? Well, we need to give an attack strategy, and that could be as simple as run, cubes, and that empowers students with a starting place and where to go from there. So read the problem, underline, name the problem type. And then we also need to give them, it doesn't matter which attack strategy you choose, and then we need to show them schematic instruction. And since we're winding down, I can't go in depth with schematic instruction, but it's great. There are graphic organizers within our Google Slides that correspond to this, and the Iris Center has free modules on schematic instruction. It's basically identifying 6 schemas that will help you tackle problems from K to 8th grade and even into high school, certain word problems. And it's looking at a problem and seeing it as a part whole and not as just an addition problem, but it could be addition, it could be subtraction. So here we see part whole, but if we're given a part and the total, we may need to subtract or count on to figure out our next part. So students aren't always adding or subtracting, they're putting the pieces of information in the appropriate spots for this. So there's 3 additive schemas and there are 3 multiplicative schemas, but we don't have enough time to really take a deep dive. We do have a free webinar on our website, SLD Supports, on Talent LMS, that goes really in depth with these schemas. So we have equal groups for multiplication, but we could be dividing or multiplying based on the piece of information that's missing. And we have to roll these out in a way that kids can understand. We don't just give them all of these schemas at the same time, but we have to roll them out over a course of weeks. Sarah Powell also has a free intervention called Pirate Math Quest for that. And this is something that has to be rolled over the course of weeks. And then our last one, as we're wrapping up, is building fluency through timed activities. And I want to show you a couple of my favorites for this. So we can use time tests as long as the students are about 90% accurate, and we're trying to get them faster. So they're not answering within 3 seconds, and we need them to answer within 3 seconds. And that will not cause anxiety according to Robin Cotting's research. And then we can do cover, copy, compare as well. And this didn't have as strong of research, but here it's very simple. You write the facts that they're working on and you have a flap that goes over it. And you make sure to maybe scribble over it or have a flap that's thicker so that they can't see through it. And literally they open it up. So if you see this resource here, they open it up, they say 8 + 1 = 9. Close, write 8 + 1 = 9, and say it aloud again. Open, compare. So cover, copy, compare. So that's really 3 exposures to the fact while they're doing this. They see it, well, they see it, then they say it, then they write it, then they say it again, and then they compare. And if they get it incorrect, they try again and write it in the 3rd column. And then we want them charting their progress and making this very low stakes. So our time test should not be graded. It should be them competing against themselves. And I'm going to show you just 2 more of my favorite resources for this. So we have incremental rehearsal, and Brian Ponce has a free website called Mind that has intervention resources. Incremental rehearsal would be flashcards, and it would be working on a specific amount of facts with the students. So you want to pick out maybe 8 to 9 facts. 6 or 7 of those are facts that they know, but they're not fast at, and they're trying to get faster at. And the first fact is one that they do not know. And so when you're doing the incremental rehearsal, and I have linked in also videos of Matthew Burns doing incremental rehearsal so you can see it done. He'll show the unknown one first. And so they see that one over and over again as they build on. So you're really narrowing it down to about 8 or 9 facts that the students are working on. And best practices for fluency is just 10 minutes a day. And it's more bang for your buck when you separate it. So they found that students were mastering more facts when they did 2 5-minute sessions of fluency. Beginning of your math block, end of your math block. You're working 5 minutes with the flashcards with a partner on facts that you need to get faster on. And then 5 minutes at the end, that's taped problems. And they found the most gains when you were doing it every day. So when you were skipping every other day, they were not finding near as many gains, obviously, but almost like not no gains, but like minimal gains every other day. But when fact fluency was done with fidelity every day, they found the most gains. And then to show you, to end on the best note, these are taped problems. I feel like I'm going to have some difficulty doing the audio, so I'm going to show you what the worksheet looks like first. So here you print out a worksheet for the week for your students, and you'll notice that they eliminate times 0 and times 1 here because we don't want to waste any time on that. That's something that students can quickly generalize. We don't need to have that in their daily practice of times 0 plus 0 times 1 plus 1. And what you do is you print this out, and there's a way that you can do it to modify it for students. But my niece has dyscalculia. We did this for a week and saw great gains with her. And we printed it out, and the audio read it, and she had to beat the tape. So she had to say 9 times 8, she had to say 72 before the tape said 72 and write it. Now, she wasn't able to write the ones she got wrong. So I just had her, because she has some fine motor issues with that too. So I just had her say the ones that she got wrong. Day 1, she got maybe 5 or 6 problems correct because it starts to repeat itself. But I told her, just let's work on progress. By the end of the week, she got almost half the problems correct. It truly was amazing, and it takes 5 minutes. So we used the same sheet for the whole week, and then she laid out the sheets and could see her progress. And anecdotally, besides the research, we're doing this with Chicago Public Schools in a community of practice. Those teachers have implemented it, and they said the gains are absolutely incredible. So I'll just play a little clip of the audio so you can see the tape that they have to beat. So you go down and find the corresponding one.
Here is a worksheet that contains a series of problems. Please check that your worksheet says 1A at the top. When I start the tape, the problem will be read, and shortly after, the answer will be read. It is your job to try and beat the tape. If you can't beat it, then the answer will be given to you, and if you wrote down the wrong answer, cross it out and write down the correct answer. Are there any questions? Ready? Begin. 9 times 8. 72. 3 times 3. 9.
So a student has to say it and write it before the tape. And then they want them to write in the incorrect ones, but I've found that hard with students. If they can do that, great. If not, they can verbally say it. It sounds like such a simple thing. It takes 5 minutes, and it's all pre-made and free on Brian Ponce's Mind website. So that is all I have for you today. And if you're interested in more, you can always email me. I will look through the chat and see those that would like the slides and get their email address.
Outstanding. Aubrey, thank you so much for your time this afternoon on explaining dyscalculia to us and how to support students who experience that. We've got a lot of people who would like the slides. Aubrey, would you feel good about maybe sending them to me, and I can email them to everyone after I get the recording finished?
Yes, and I can send the concrete presentation that we've done in the past to you as well, and you can forward that if people want to watch it, they can watch it.
Okay, that'd be great. So I'll be following up tomorrow with a link to today's recording, a link to the slides, and the resource packet as well. Any questions for Aubrey? I know we're a little after 4 o'clock. So if you've got any questions, type them into the chat, and we'll see if we can't quickly get you an answer. Looks like a lot of thank yous so far. Amber's question, does this webinar provide a PD hour? The answer is yes. I'll be sending a link to the webinar evaluation in tomorrow's email with the recording. Once you complete the evaluation, you'll be able to download the ISB evidence of completion form for entering your 1 hour of professional development credit for your attendance this afternoon.
And we do have a social media presence. We have Facebook, the SLD Support Project. We have Instagram, TikTok, YouTube channel. Anything else, Robin?
Oh, I think that's all of them.
All right, well, I don't see any questions, so I'm going to stop the recording.